Welcome to this tutorial about Accuenergy meter configuration for independent channel applications. In this video, we will go through the proper wiring guidelines, parameter settings, system configuration, data log setup, and data log extraction. This guide is intended to help installers and users understand the correct procedure for configuring the Accuvim meter for multiple single-phase loads, including proper seat installation and voltage circuit connections. Before configuring the meter, it is very important to know how to wire and install the current transformers. In a two-wire single-phase loads, there are two ways to connect the loads. One is the line-to-line loads. In the Accuvim single-channel meters, you need one CT for each load. The installer has to check the phasing of the load with respect to the phasing and the voltage input of the meter. How are you going to do it? For example, you have a single-phase line-to-line load connected to line 1 and line 2. But in actual scenario, normally this area is covered. So you don't know this single-phase load is connected to which phase. So you have to test by tester at this point where it is accessible to connect a voltage tester. At the terminal of the meter, there is terminal for voltage inputs. What are you gonna do is your tester, one of the leads you will connect to V1 of the meter, and then the other leads you have to test each line, first this line and then second line. Whichever shows a 0 volt, it means that is the line 1. For example, becomes 0 volt here, then you can identify the first line to be line 1. Next is you have to connect your test leads to line 2, and then you have to test the remaining line, which is the second line, this line. If it shows 0, that means this is line 2. But if it is showing also voltage, the next thing you have to do is to shift your tester to the line 3 of the terminal in the meter, and then again test this circuit. When this becomes 0, while this is connected to the line 3 voltage, it means this is line 3. So now you have identified that your single phase load 2-wire is line 1 and line 3. So in our case, we have identified that our voltage is line 1, line 3. To see that in the table, we have to go to this table, line 1, line 3, or line 3, line 1. If the phase combination is line 1 and line 3, then you have to install the CT at line 3. Same case for the remaining combinations. If the load is line 1 and line 2, you have to install the CT in phase line 1. If the phases are line 2 and line 3, you have to install the CT line 2. This diagram is showing how you will connect the CT to the meter. Like as explained before, if the load is line 1 and line 3, you will install the CT and line 3. If the combination is line 1 and line 2, you will install the CT in line 1. If your load is line 2 and line 3, you will install the CT in phase L2. So it is always required to know what phase for each line that you are installing for all the loads, loads 1, load 2, load 3, and maximum load 4 for a single channel meter. It is possible to use different combination. Here it's line 1, line 2. Here you can install also line 1, line 2. You can install here any combination of phases for each channel. It is independently configurable which phases for each load. Later, we will show you how to configure for each channel depending on what is the phases for each load. Next is line to neutral loads. Like in the line to line loads, you also need only one CT to measure for each load. Same procedure, the installer has to check the phasing of the load with respect to the phasing in the voltage input of the meter. The CT should always be installed in the phase line of each load, not in the neutral. The procedure for identifying what is the phase of the line is the same as what we have shown already before. Using a voltage tester, connect one of the leads to the meter terminals, voltage input, and then the other leads of the meter to be connected to the terminal of the circuit breaker where you are installing the CT. The table below shows where you will install the CT. For line 1 to neutral, you have to install the CT in the base cable. For line to neutral, you have to connect CT in the line 2, which is the phase cable, same as for L3. An example for the line to neutral loads are shown here. Load 1 is line 1 to neutral, load 2 is line 2 to neutral, load 3 is line 3 to neutral, load 4 is line 1 to neutral. As mentioned before, each channel is independently configurable for any phases. It means the first channel can be line 1 neutral, the second channel can be line 3 neutral, or line 1 neutral as well, or any phases for the remaining channels. For the voltage measurement and wiring, there is direct to bus bar connection. It means you are not using voltage transformer. As you can see in the diagram, that the meter is directly connected to the bus bars through the protection fuses. This is another way to connect the voltage input of the meters to the bus bars using a voltage transformer with both fuse protections in the primary of the transformer and secondary of the transformer. In this case, you have to program the meter based on what is the actual ratio of this transformer. For example, if this is 480 volts and here it is 120 volts, the ratio should be programmed in the meter during configuration, which will be shown later. This diagram shows how you will connect the power supply of the meter. It can either be derived from the voltage from the meter input, or you can take this supply independent from the voltage input. The advantage of providing voltage here separate to the voltage input, like for example, this voltage input is connected to the UPS, you will always have a power even there is no power in the voltage input. The diagram shows a single fuse because it is assumed to be line here and neutral here. But if your supply here is derived from a line-to-line load, for example, this is line 1 and this is line 2, you need to provide two-pole fuses for the meter. That is how you will wire the meter. We have shown the CT wiring input, the voltage wiring input, and the power supply input.